right, I think we can get this one started here. First off, I want to thank all of you guys for joining. It's a pleasure being here again. Today we will have a community spotlight session. We want to showcase some of the early proof of concepts, hackathon projects, and pre-alpha DApps that are being built on Cartesi Rollups. We have some great guests here today that will talk about what they build and also share their experiences. Again, thanks so much for joining, guys. This is also meant to be an introduction for new builders to the possibilities of Cartesi Rollups. If you're attending ETH Denver or future hackathons, this is a great time to ask questions to the builders and get some potential inspiration for your future projects. Just for your information, we will also be recording this session, so you can always rewatch this later on if desired. So let's go over the agenda real quick. So we will start with, by the way, can everyone hear me?
Yeah, we can hear you.
Yes, we can see you clearly.
Double checking. Great. Well, the agenda will be, we'll start with an introduction to Cartesi in case there's some new joiners here, especially for hackathon participants later on as well, just so you get a kind of intro on what Cartesi Rollups even is. We will go to the main part of this event, which is the project and proof of concept showcase. We will have our different speakers. Then we will follow up with an AMA where we can, ask questions to each other and discuss some of these projects, also discuss potentially new ideas that some of you might have. And then we'll discuss what's next as well afterwards. To kind of introduce everyone to Cartesi Rollups, or at least the ones that aren't too familiar yet, Cartesi Rollups are application-specific rollups infrastructure with a general-purpose RISC-V based virtual machine. Now, today we face two main limitations in blockchain development, which are computational scalability and programmability. Now, as most of you know, under global consensus, such as on Ethereum, every node has to validate everything. This you're competing with other dApps for block space. Your dApp needs to be able to outcompete a popular application like Uniswap, or maybe the latest NFT drop, to be viable and to be able to survive on that chain. When demand for block space is high, gas costs can price your application out completely. Now, these issues have led to new scaling solutions such as rollups, and Ethereum is now following this rollup-centric roadmap as well. Now, rollups are great as they move computation off-chain and batch transactions. In the case of optimistic rollups, we only use Ethereum as a fallback mechanism in the case of a disagreement or dispute between rollup nodes. However, rollups under global consensus will eventually face similar issues, as rollup nodes need to validate everything happening on that rollup as well. Now, what if instead of validating everything, nodes only validate what matters to them? This means that your application could have its own virtual machine and doesn't have to compete for block space with anyone else. Well, that is what we're proposing with Cartesi Rollups, which are application-specific rollups. These application-specific rollups provide tremendous computational scalability. They are modular execution environments that can sit on top of Ethereum or on top of layer 2, such as Optimism and Arbitrum. The choice is yours, basically. Now, these application-specific rollups also allow us to tackle the second issue, which is the lack of programmability in dApp development. Today, you're mostly restricted to the EVM or Solidity. Now, what we did is we developed a custom virtual machine based on RISC-V. And RISC-V is an open standard instruction set architecture. Thanks to the computational scalability provided by application-specific rollups and this custom RISC-V virtual machine, we're able to boot a full Linux OS on top of that. This means that you have access to the tools, languages, libraries, and much more that run on Linux and compile to RISC-V to develop your apps. To conclude, Cartesi allows you to elevate your smart contracts to decentralized Linux runtimes, while still having the security guarantees of Ethereum or the layer you select. As a developer, you thus have tremendous computational power and full programmability at your disposal. Imagine all the cool stuff you can build by removing these constraints. That's all from me for now. Let's now dive into some of the real proof of concepts, hackathon projects, and early dApps that were developed on Cartesi Rollups alpha testnet. I want to highlight that this is still experimental tech. These are not final dApps yet. Most are great proof of concepts and showcases of the possibilities and future opportunities for dApps. I want to thank all the early builders that started building on Cartesi from the early days. Thanks so much for your amazing contributions. Let's try to limit talking to around 5 minutes per dApp maximum. Please feel free to drop your questions in the chat. We'll also have time for longer discussions and questions after the project showcases. Today we will cover several verticals, right? We try to categorize these a bit. We have some on-chain games projects, some machine learning projects, some projects related to generative art, IoT, to trustless automation, and finally to competitive programming. Some of the guests were able to join today, and some others were not available, so we will showcase their dApps on their behalf. So let's get started with on-chain games. I'd like to start with Ultra Chess. Blockchain, if you'd like to unmute yourself and talk a bit about the amazing on-chain bot versus bot application that you're developing. Okay, I see Blockchain might have some internet issues right now. We will get to this one in a second. Maybe Dimitar, you can talk about Cartesian Battleships, which is also an amazing application that's being built.
Sure. Let me share my screen and do a quick demo of the application that we have. All right. So together with Cartesi, we've developed a turn-based game which is called Battleship. It's a recreation of the popular game from probably everyone's childhood, the Cartesian Battleship game, where the game is between two players playing against each other. The goal of the game is to guess the location of the battleships of the opponent and destroy them. So this is the representation of the traditional game. And on our previous presentations, we went through the complete gameplay, so everyone could review the recording for this part and basically see the game in action. But what I would like to focus for today's presentation is basically how the game works. The architecture of the game is based on a Cartesi machine and a game client. So on the Cartesi machine, we have the Battleship game server, which is responsible for the gameplay, for all the verifications of the game. And then we have the Battleship game client, which is communicating with the Cartesi machine slash rollups through the GraphQL and inspect API, and also using notices. So this is how basically the Cartesi machine is communicating with the client of the game, and basically the client is coordinating the different moves of the players and visualizing them in a nice visual way. In addition, we also have, let's say, additional layer that is dedicated to basically provide transparency and control the fair play of the game. So we have different options to validate the player moves, and also at the end of each game, we're validating the entire game based on the all the moves that the players made, and basically then the game server is the one that who pronunciates basically the winner or the loser of the specific game. And a bit about the current version of the game that we have. So as part of the implementation, we have also something that we call instance server The idea of the instance server is to increase the performance of the game and basically to reduce the cost to the rollups and the blockchain. But obviously, this is not the focus on today's call. So the focus will be the Cartesi rollup and what we are doing in the rollup. And specifically all the stuff that is related with the gameplay, the game management, and the game verification. Here is how the traditional game looks like. The two players agrees to start the game. They create the game, join the game, and start sending moves. And at the end of the game, one of them confirm win, the other confess loss, and then the game server will verify the game and will basically send verification to both of them and confirm whether the game was fair or not. Let me just switch quickly through the next screen here. Yeah. So in addition, let me just, yeah, that's it. So in addition, we have a layer that is performing a kind of an encryption of the players' boards. So the idea is basically the boards to stay hidden for both of the players until the end of the game, so no one is able to cheat and somehow to compromise the gameplay. So that's the area of the rollups and the game server in general, which is the complicated part of the application and consumes a lot of computations. And yeah, this is where rollups and the Cartesi machine are basically helping us a lot with all the logic and basically all the logic and the rules of the game that need to be carefully followed and verified during the game. So yeah, that's the presentation in short with the technical aspects of the game. If you have specific questions, the developer of the game, my colleague Lutri, is also online, so we can answer your questions and yeah, we can use the discussion session later for that if you want.
Thanks so much, Dimitar.
Yeah, I don't really have too much to add from the last presentation.
Yeah.
But yeah, basically Ultra Chess is just an AI versus human chess, on-chain chess platform.
Sweet. Yeah, so basically on-chain bot versus bot or bot versus human. For anyone interested, you can also look a bit into the video that was shared in the chat. But essentially, anyone can develop RISC-V compatible chess bots. They basically compete against each other, which is pretty cool. And in a way, also there's an intersection with the other category, which is the ML category that we'll touch on in a bit. I don't know, Carlo, do you want to share anything else on this game, or we can also move to the next game as well?
No, just adding up that, as Max said, and as Glockchain presented the other time, this is a game that demands a lot of processing because you have both bots executing from scratch up to the end of the match. So once again, it's something that with the gas limitations of blockchains, it's not feasible. Not only because of the processing, but also the cost would be prohibiting.
Indeed. Great. Yeah, we can dive a bit more into some other potential implementations of ML and gaming later on in the discussion, maybe. I know Blockchain, you have some nice ideas there as well. Let's go to Dinder. Teddy or Eric, do you guys want to give a quick presentation or explanation on your experience and what you've kind of been building out here with Dinder? So super cool game.
I think Eric can quickly go through the deck that we showed last time, the summary.
That would be great.
Sure. So basically it's what is Dinder, why on chain, and why are we using Cartesi, and we'll have some developer tips later. So Dinder is a competitive puzzle gaming with RPG elements, and the core mechanics is the match 3 elements, and we do have NFTs. And here's a quick demo video I can show you guys. I think, not really sure if you guys seen this already, but I'm just gonna show it. It's a short video. And for Cartesi, I think our game is very similar to the other games that were turn-based. So we're able to prove transparency, fairness, and RNGs. I think we went over this last time. So I think today we can go over some of the tips for developers.
That'd be
And
great.
maybe Teddy can go deep into this part.
Sure. I think this slide is mainly for like new inspiring developers for Cartesi. So first one is to take advantage of host mode if you need to do frequent dev work. It's just much faster, it's easier to set up, and it's just more agile. And the second one is to limit the use of the inspect API. At first glance, it looks very convenient, but then the convenience comes at a cost and can greatly slow down your DApp if you use it too much. So for our case right now, we're only using it for the initialization of a client or restoring state. So which means that most of the time you're going to be querying data through notices and vouchers. So you have to keep in mind like how often you read the notices, and if it makes sense to have some kind of central server to keep track of that. So for us, we actually have a side server that collects the notices and then aggregates them for our game clients to pull from. And then last of all, if you want to test the voucher functions, remember to test it in production mode. It doesn't work in host mode, I believe.
Interesting. Yeah, that's great. Thanks for sharing that, Teddy. Anything else you guys wanted to discuss here, or should we move to the next one?
Do we have anything for poker?
Let's move to the next one. Poker, well, it's I think there's not much to add, similar to auto chess, because we've talked about it last time, and it's also a turn-based game, and much of the advantages are going to be the same as the other turn-based games.
That makes sense. Sweet. Okay, let me try to share my screen again. Blockchain, would you want to give like a sentence or two on Game of Life or Colosseum?
Oh yeah, Game of Life. Yeah, that was a player versus player Conway's Game of Life, where users sort of battle for ownership of a grid.
Yeah. What was your experience building that? Or I know you built it during a hackathon in San Francisco.
Yeah, it was fun. I might end up releasing that during the December.
Ooh, okay. That'd be sweet. Some early alpha. Okay, very nice. But yeah,
Same
I'm
with
also curious
Colosseum.
about. Oh yeah, Colosseum. Yeah.
Yeah, same exact thing with Colosseum. Yeah.
Okay. Blockchain, do you have any like tips or tricks for developers around building games?
Have fun.
All right, that's to the point. Yeah,
Just
maybe
just giving a bit more details on this. So both Live and Colosseum, what happens is the game simulation logic runs inside a Cartesi machine, and then you can use the reproducible results outside. So in case of Live, as Blockchain said, this is a simulation of Conway's Game of Life, and you have multiple players. They set up their patterns, their initial patterns on the grid, and then a simulation of a certain number of rounds happens inside the Cortez machine. And after the simulation is done, you just count how many cells each player has, and the player with most cells wins the game. While in Colosseums, what they did is they ported this retro game engine inside the Cortez machine, and they made this automated fighting game with these characters that battle each other. And after that match happens inside the Cortez machine, they render it in old school graphics and show on their client. So this is just to give an idea of how the separation is done between what you process inside the Cortez machine and outside of the Cortez machine. Basically, whatever affect the results should be processed inside, but graphics, user interface, all this stuff can be done outside with no issues.
Oh yeah, exactly.
yeah, very interesting. On-chain games are definitely an interesting topic to look at if you're doing a hackathon and want to build something on Cartesi. Maybe we can move to the next section, which is machine learning. Marcus, I think this is your slide basically. Maybe you want to unmute yourself and share your slides. I know you've worked on these 3 very cool proof of concepts. If you're available now, that would be fantastic.
Sharing my screen.
Awesome.
Let me know when everyone can see my screen.
Yeah, we can see your screen, but your mic is a bit low. If you can raise it a bit.
My mic is everything okay now?
This is better.
Yeah, now it's good.
Okay. Thank you, Max. Thank you, everyone. Greetings to all. It's an honor to be here today. Just allow me to introduce myself. I'm Marco Souza. I'm senior software engineer at Locus Software, and today I'm here to share with you some details about the proof of concept apps that we've created in collaboration with Cartesi. And I hope this proof of concept can serve as the foundation for a larger mission which we are all involved, right? Just get started. Those. The 3 DApps I'm bringing today is the Iris classifier, the Titanic survival, and biometrics classifier. I will try to emphasize the process of the development and offer some examination of the architecture and the challenge I've encountered and some results I've achieved. So without further ado, let's get started with the Iris. The Iris classifier is for those with some background in artificial intelligence. The Iris dataset is likely a familiar concept. The standard approach in this dataset involves using logic algorithms to predict new samples imputed by the user. It's a flower dataset, so the user will input metrics like size of the petals and sepals, and some algorithm will predict what kind of flower the user is inputting, right? But the problem here is how could this be achieved in the Web3 environment? And for instance, we have the core functions of the KNN. In this case, I will be using the KNN algorithm. And we have the core functions of this algorithm and written in Python for the backend. And this backend is capable to perform all the computation logic we need to solve the problem. And is written in a standard development fashion, so only adding the Cartesi API functions like handle advance and handle expect as meant in the documentation. And the architecture, we have the standard Cartesi Rollups architecture. And for our example, I think I just pressed it 2 times here. But for our iris classifier architecture, we just have to add the kdnn.py to the backend. And we also developed a nice React frontend to interact with the rollups and design it for user experience as well. And here we can see how can we send this information from the backend through transactions, and that's more like it. Here I can show to you guys a small video for how this translates into a system, right? And the user fills the form, and we have some animations, and the transaction is sent to the backend as we are used to. And after a while, the frontend will exhibit a good image about how the class predicted by the backend. And that's what's like it about this proof of concept. We can now proceed for the next one. And it's the Titanic survival. It's a truly innovative one because we aimed to bring more complex machine learning models to life in the Web3. And normally using Python, it provides us a plethora of ready-to-use complex models through the well-known package called scikit-learn. And for this project, we selected the Titanic dataset. And the problem of this dataset consists in use previous information about the passages of the crash. In our case, we want to use this information for knowing if some new passengers would die or survive the Titanic crash. And the approach seems identical to the iris classifier, but we have had a major problem here to deal with because I guess I pressed it again. My keyboard is just playing tricks with me. But the approach here was like the scikit-learn package could not be used straightforwardly due to unavailable of its non-ported RISC-V dependencies, such as pandas, and in the time of this project, also NumPy. And to overcome the challenge, we trained the model outside the Cartesi machine and converted it to pure Python code using the M2CGN library. And after that, the model goes along with the Python code that does all the logic predicting the new user's input. So let's see again how this translates in a fully functional program. The user will, of course, fill the form. It's very similar in terms of functionality. It's just sending information for the backend. And we also tried to implement a good animation for simulating the Titanic crash. And after a while, the front end will receive the notices with the result of the predicting. And with all aspects of this architecture failed, let's move for the final proof of concept of the day's presentation. That is the biometrics classifier. Last but not least, it was a result of all my prior experience developing DApps with Cartesi. It was an ambitious one because we aimed to leverage my expertise in biometrics and bring it to Web3. In my research, I've discovered some potentials of biometrics by enhancing security of the blockchain systems through integration of IoT devices or not, among other applications. And we wanted to test this potential with this experiment that blends artificial intelligence, image processing, and computer visions. And despite of the complex concepts involved, my objective was simply yet challenge that if I could create a system that processes images and use a machine learning model to predict whether a given fingerprint image was genuine or not, in the Web3. And thanks to the Cartesi, the answer was yes, though the journey was rich with not without challenges, because we will see in this architecture here the normal workflow for a biometric system is like to extract crucial information from images and this and convert it to feature vectors. These feature vectors are utilized to train a model, enabling us to predict the class of our new input based on this feature vector. And to accomplish this task, we leverage the power of OpenCV, a well-known library for image processing and available for C++ desktop items systems, and ported to RISC-V for use within the Cartesi machine. And also we used this OpenCV and C++ to write a feature extractor responsible to turn all images into training vectors. And this enables us to perform all the necessary operations for extracting information from images and inside and also outside Cartesi machine. Enable OpenCV here was also opens opportunities to implement any other kind of image processing system. So we also have a published article on Medium on how to do this cross-compilation process. And for the model, we employed the same strategy of the Titanic classifier, training the model outside the Cartesi machine, converting to pure Python code, and for the implementation within the Cartesi machine. And the feature vectors of a fingerprint dataset were extracted to train the model using the standard training strategy. And the final step was seamlessly send actual images to the front end to the back end. And here we have to consider some limitations of the system, because the communication between the models is facilitated through blockchain transactions, and therefore images must be transformed into base64 strings and sent as a part of the transaction payload. However, this presents a challenge because images often generate large strings that exceeds the permitted size for a payload. To overcome these limitations, we devised a strategy of breaking down the image into chunks and send them individually to the backend. Of course, the backend is prepared to reconstruct these chunks into a complete string to convert back into an image and then be extracted by the feature extractor that also is inside the Cartesi machine. And with all this ready, we have successfully developed an end-to-end Web3 biometrics verification system. And let's see how this translates into a fully functional system. And in this system, the user has to only select images from the gallery. We have this gallery in the front end, and these images are also separate from the training step. Is really new images for the model, and so on. A set of transactions will be sent to the backend that has the chunk with the chunks of the images, and we will see here like all images often generate 4 or 5 chunks of strings to be reconstructed there. And in the end, the system will give us the predicted class of the finger, if it is fake or if it is live. And about this, that's it. I think that's it for for today's presentation. In conclusion, this has highlighted the potential of Cartesi technology through the demonstration of these various proof of concepts that delve into complex concepts and approaches from the fields of machine learning, computer visions, and imaging processing. And I really hope this presentation inspires authors to bring their ideas to life, even those who, without prior Web3 experiences, to not be intimidated by the Web3 space. With the assistant, the Cartesi technology, building in this arena has become a much easier experience, and I'm living proof of that myself. And that's it for today's presentations. I'm open for questions, and I'm would be happy to discuss my experiences. If not, I'm really grateful for the opportunity to talk about this proof of concepts. Feel free to contact me if you have anything related to them, and I will be glad to answer. Right, that's it.
Awesome, Marcus. Very, very cool. Good stuff you built. Carlo, do you have any thoughts about this that you want to share?
Yeah, so when Marcus developed the Titanic as example, for instance, it was very early on the development of the framework, and he didn't have NumPy inside it. But hopefully, new developers can have a much easier time, and we do have NumPy ported now, along with other libraries.
Awesome. Super cool. Let's go to the next one. I don't know if Ritvik and Utkarsh, are you guys here to talk about Be My Coin?
Yeah, we're here.
Hey, Utkarsh, how are you?
I'm great.
Sweet. So do you guys want to kind of talk about Be My Coin a bit?
Yeah, sure.
Awesome.
I'll just share my screen.
Yes, sure. Feel free to share your screen. I cannot see it yet, but yeah, just a little bit of background. So while it loads, Utkarsh, you might want to cancel the sharing and reshare it. We've been facing a few issues with that.
Okay. I'll just stop sharing it and try again.
Thank you. Yeah, so just a bit of background. So this was one of the projects at ETH India. So really great to have you guys here. Still loading on my side.
Here as well.
Yes.
Now it's loaded, yeah.
Okay, great. We've done like 20% of it. All right. So let me introduce you first. So like me and Ritvik, my partner, I'm from InsurTech and he's from MedTech. We got together at a hackathon in ETH India, and we thought, why not, create something from our domain? And we're just figuring it out, and we're like, insurance cannot be done on, a decentralized platform, especially for physical goods, products, and services, because it will be very difficult to know whether that, any damage is caused or not. And me specifically, from in the insurance industry, we sell motor insurance here in India with HDFC Ergo. So we just stumbled upon the Cartesi. There was a presentation of Cartesi. We stumbled upon it and we just got it right there. Like, this can solve our problem. So I'll just introduce you to the problem first. That, it's very difficult to insure physical products because there is no way to know, at least in a decentralized world, because you don't have any, salesmen or any insurance agents or investigation agents who can go and, examine your car or anything. So we prepared a product in which what we do is we put up a sensor. So here in India, starting from 2015, every car in India has a OBD sensor. It's an onboard diagnostic sensor. It must be there in your car as well. It's just beneath your steering wheel. So what we added was we tried to hack together a solution in which we basically take in data from this OBD sensor and we ping it on an ESP32. ESP32 is a expressive chip. It's a small chip on which you can, it has a Bluetooth and a Wi-Fi connectivity and even data connectivity. You can add a SIM and push the data on the cloud. So what we do is we collect this data and we try to assess a driving behavior, as to say, of the driver. And based on that, you're given in quote for the insurance premium. So what we do is we maintain a big pool of Bima coins, and whenever you come to us, we put in this device in your car, and based on your driver index and behavior, we give you a particular premium that you have to pay. Depending on your driving behavior. If you're a good driver, you pay less premiums. If you're a bad driver, you pay more premiums. It's completely decentralized. No, the problem that we faced was what if in any centralized world, if I'm collecting this data, tomorrow I can go and say, just a second, just. Yeah, so tomorrow I can go and say everyone is a bad driver and everyone should pay more premiums. So we hacked together a solution with Cartesi, wherein we collect this data on the device, and after a few moments we publish this data. We hash it and we publish it on the blockchain. We keep it on Polygon, and after that, we issue you a premium that you have to pay this much Bima coins every month or maybe every year to carry on with your insurance. Now, let's say there comes a dispute wherein that you don't agree with us, that no, I'm a Michael Schumacher type driver, and what you're trying to tell me is wrong. That I'm a really good driver, and you're giving me a very bad driver index. At that time, what we do is we pull in this data from the blockchain into a Cartesi machine. We spin up a Cartesi machine, and we pull in that data, and then we have an algorithm, the same algorithm that we use in the first place to calculate your premium, your driving behavior. And then we run it again on these Cartesi machines, and we try to do a poll that whether the hash of the result that we computed earlier matches with the hash that we get right now with the same data. If both the hashes are right, then all is well, all is good. Your premiums were issued to you in the right way, and this does create a trust with the people that it's a completely fair and transparent compute. If it doesn't go well, then this is where the Cartesi compute comes in the picture, wherein we can go to the specific point in the computation where it actually went wrong, and then we can further dispute it as to why it went wrong and why is it showing the other result as compared to the one we computed earlier. So this is the whole project. We did a small POC of the same. I'll just ask my friend Ritvik if he's here to explain the shape and how we computed the driving index. Is the guy there? I'm audible? Just to check.
Yeah, you are.
Yeah, just a second. So Ritvik is server muted. Can you unmute him? His name is, I guess, IDRIT. Yeah.
Hi.
It is.
Am I audible?
Yeah.
Okay.
Yeah, we can hear
Yeah,
you.
you're audible. Yeah.
Yeah, so basically, our hash. So we were storing in Polygon the hash of all our logs that was being sent by our vehicle data. So there was a contract. Wait, I'll share my screen. Yeah, is my screen visible?
Yeah, it is.
Okay, cool. So first of all, we have a log hash factory, which is invoked whenever the car detects a crash on the OBD sensor, and it gets a hash, and it calculates it according to the algorithm that we have, and we store it as a log hash as a transaction in Polygon on chain. Then we have a driver index mapping, which takes into the account our seatbelt engagement, braking intensity, average speed, etc., etc. This was a POC, so we just took in the data, and then we calculated our driver score, which was basically we multiplied everything by 10 and then we added them together to just get a score of some kind, an ELO rating or something like that. Then we push this in our on the chain, and that is it on this side, on Polygon side.
So yeah, again, like based on this, you are issued your premiums for the insurance that based on this driver index. And we, at the time of dispute, we spun up a Cartesi server. I'll just show it to you. We try to inject the exact same data inside it. I'll just share my screen. Yeah. Can you see my screen?
Yeah, it's coming.
Okay.
Yeah, we can see.
So we here, if you can see, we try to inject. We tried injecting the same JSON. That is, the seatbelt was engaged 20% of the times. Average speed was about 40 kilometers per hour. Non-indicated turns were about 34%, and mileage was about 17 on average. When we inject this, we do get it computes again the same algorithm that with which earlier we computed and gave you the driver index, and then you can compare and see whether this works or not. Now, we did it just for insurance, but then later on we realized this kind of infrastructure can be built for decentralized IoT systems, wherein it could be logistics, it could be anything, wherein there are logistic containers from which we're connecting the sensor data and then publishing the results on the cloud. Now, just to remove any any false doing or any wrongdoing from the shipping company's end, you can always question that, because now you have the data, you can run it on an independent machine, and then you can see the result as to whether the let's say cooling systems fail or not, whether the cooling systems were right on time or not. And according to that, you can claim insurance.
So for industrial applications, industrial insurance, there also this can be used.
Yeah, we're still in the POC phase. We're like still in development. We don't have a UI as of yet, but we're building on the backend tech, so that once we get it through, it's really difficult to in a decentralized world, you have to be very careful when you're moving data, because sometimes I see like a lot of people move data to a centralized system and then get it back to a decentralized system. That defeats the whole purpose of Trust. So we're trying to be very careful with that. We're trying to push data this time directly from the hardware sensor itself. So the hardware sensor will directly publish to the Polygon, and then from there it will be taken on further. So that's about it. If you guys have any suggestions, we're just starting out in this space. Any guidance or any mentorship is welcome.
Awesome. Thank you so much, guys. This is super cool as well. Different use case. Carlo, do you have any thoughts that you wanted to share as well?
As I said, it's a great idea. They have this problem that blockchain faces of oracles, and as he said, in the insurance space, you have this issue that when an insurance is denied, you don't know why. It's an internal calculation they do, and they just say we're going to pay or not. And this product of theirs is bringing transparency to this. And it's also really nice that since this is a hackathon project, the first calculation they did for scoring was a bit simpler, just a couple of metrics multiplied by some weights. But in the future, they can just leverage the Cartesi machine to do a more advanced calculation, like using predictions with machine learning models and other more heavyweight tooling.
Super cool, super cool. Thanks so much, guys, for joining. Love also the profile pics, the cats. Super cool. Next up, we have Garon Shane. I don't think that the team is present. If you are, please unmute yourselves. Otherwise, Carlo, if you could give a little high-level overview of this project. Also using machine learning, but this time in the case of predicting real estate prices and housing prices. Yeah, Carl, I think the team isn't here.
Okay, so just an overview of this project. So this was also developed on ETH. And in their case, what they wanted was to make this project in which they calculate the estimated value of a house based on some metrics. So this project used machine learning to use input information about housing, like number of bedrooms, the area, and fed those factors into a machine learning model. and then this learning model would estimate the value of the asset. The idea is tokenizing these assets so that you can have shared ownage. And a really important point is actually having the value of the assets. So this is the part that they implemented on Hackathon, the estimation of the value of the house.
Super cool. Also an interesting one. Could also be applied, I suppose, to other things than houses, maybe.
Yeah, this tokenization of economy is something that's really hot. People are doing this ranging from hotel rooms, housing, vehicles, production, a lot of stuff.
Definitely. Thank you, Carlo. All right. Now we will have one project on generative art. And I think Maxime is in the room to talk about FR Mandy. Maxime, if you're here, the stage is yours.
Can you hear me all right?
Yeah.
Hey, cool. Yeah, nice to see you guys again. I haven't got a presentation. I don't expect to present anything today, but I could generally talk about what we did.
Yeah.
And let you know what we're up to. But yeah, from Andy, that's basically just concatenation of three names: Fran, Max, and Andy. We're basically a Rust developer team, and yeah, we came across Cartesi offering us the ability to build our apps in Rust, so we thought we'd give it a go. One of the key aspects of Cartesi was that we could do a lot of compute, and obviously building Mandelbrot requires lots of iterations, can be quite CPU intensive. So we thought it would be a good idea, and then we would generate it as an NFT and then store it back to Ethereum, back to chain. We got so far as basically building the example in Rust, and we hosted a small site using some WAGMI controls for the user to basically go into a raffle. I think it was something like that. They would enter some inputs, which would obviously be passed in, which would basically execute a transaction on Ethereum, and then that would then get picked up by the Cartesian machine. It would generate the Mandelbrot as an image. At that point, we just saved it to the machine. There was some way to access that. We didn't get that far, but that's pretty much where we got to. We did find, we also gave some feedback to you guys about it was quite difficult to set up. I think the orchestration of all of the containers quite difficult, especially as a newcomer to this model. So, but no, it's been great seeing some of the projects so far on Cartesi. It's obviously you guys have got a really good understanding of the architecture. It's quite good to see. We obviously did this as a learning exercise to try and figure out how to interact with a roll up and a level 2. So. But yeah, that's pretty much it. And that's awesome. Yeah, I think we did a commit to you guys. Hopefully that's useful. That's in your examples. But I mean, going forward, maybe we're going to try and potentially pull up maybe a proof of concept. We're actually indexing data, mainly sourcing pricing data for like finance applications and so on. So maybe there's something there that we could do or extend. Maybe there's something that you want to do with pricing data, as obviously using pricing as an oracle, that you could make some decisions using a Cartesian machine and write them back to chain. Maybe like for some risk management or some rug pull detection or something like that. I don't know. Sky's the limit, I guess.
No, 100%. That would be awesome, Maxime. We should talk about that offline. There's a project that will come up a bit later in the DeFi section that actually tries to calculate a risk score based on different inputs. So that would be super. Something like your indexing product might be quite useful for that.
Yeah, cool. Yeah, definitely. Just get us in touch and give us a shout offline and we can have a chat.
Definitely.
Excellent.
Cool.
Thanks so much.
Yeah, thanks for joining. Carlo, do you have anything you want to share here?
No, as Max So basically, this project was really interesting. There are a lot of NFTs out there, but you basically are purchasing just a reference to the actual NFT, to the actual art. And in this case, you can prove that your art is that one, that no one tampered with it on a server, no one swapped the image of your extremely rare NFT for a common one, or change your art, right? So it's a different take on NFTs, and it's a very interesting one. And as Max said, later on we'll talk about a risk engine using Cartesi machine.
Fantastic. Thanks again, Maxime. Let's go to some IoT now. I'd like to invite the Web Chefs team to talk about the parking DApp that they worked on. This parking POC, which is quite nice. Emil, I don't know if you're here and if
starting to share, hoping everybody can see my screen and hear me.
Yeah, loaded.
There you go. That's here.
So I'm Camille from WebShips. I'm here with Carol and David. We are coming from
Hello.
Web 2.0 world, and we mostly do business application, which is your typical ERP, CRM solutions. For the application here, we did a parking app, and it's basically a situation when you can pay for parking spots using Ethereum transactions and using MetaMask as your login. So we try to replicate the client API architecture in my repository. If anyone's interested on how this can go together, we've set up a Vue boilerplate and a Rust backend. With the Rust backend, we simulated something that I don't want to say framework, because the framework is a big word, but we've simulated a typical API with Diesel as ORM and with request and response structures. So our main goal for our learning experience here was how do we switch from Web 2 to Web 3, and we did just that with the parking app, and it wasn't working like just before this presentation, but it came up live. And as you can see, you have this red car, and this is actually simulates your car and zones here in Poland. And this is basically the zones we actually do use. You have different price for zones, and with Cartesi, you can leverage this what they call an inspect state to get the price of the zones. All of the information you see here, those are stored in blockchain in our SQLite database. And hoping I will be able to successfully buy a ticket using my MetaMask account. There we go. And as you can see, this is your typical Web 2 application, but this is all stored in blockchain, and using the payments are using Ethereum. We have prepared some modules. So the simple module you can see here is for drivers that I just want to pay for parking tickets. We also did a ticket validator for some city officials that want to check the parking ticket. You can use this part of application. And what we got from the experience with Cartesi is how with this technology it's easier for us to transfer from Web 2 to Web 3. and using the syntax we know, we can deliver pretty much a very scalable solutions for our clients. And if you are interested in seeing, some of the examples, please free to reach out. We have set it up as a boilerplate, so if you wanted to start a Rust and Vue app with Cartesi technology, just give us a shout. And that's it. Anyone has any questions?
It's awesome. Super cool. Love how you use SQLite and everything else. Makes a lot of sense for this type of application. Carlo, any thoughts on that here, or we'll move to the next section, and maybe Camille discuss some other use cases later in discussion session. Thanks so much for joining again.
No worries.
No, it's just a great example of how we can leverage Cartesi and blockchain to add transparency to things that we have in our daily lives. And uses database, Rust, and a lot of tech that Web2 developers are used to.
Sweet. Okay, now we have one example that is doing trustless automation. Automati. I don't think we have the team here present today. But Carlo, I think you can give a very short kind of explanation of why this is also an interesting DApp idea.
Yeah, sure. So this is an automation project that is for the ones that are used to Linux. It's kind of like a cron job. So what happens is that you can schedule certain intervals in which you want some task to be performed. And in this project, they have the ability to execute arbitrary computations by leveraging the Cartesi machine. So you can say, at this time, I want you to do this calculation, for instance, of, the average price of soy, or anything that you want. And this thing will be performed at the given time that you want inside Cartesi. So you can always check that the execution was performed correctly, and that whatever task you wanted to be executed was performed without tampering or any modifications. And it's a hackathon project from ETH India as well. I don't think they got to the point in which they use vouchers to bring back results to the blockchain and automating tasks in other smart contracts, but I think that was one of the future works they wanted to perform. But it's really interesting. It can be used for things ranging from tasks that you want to do periodically, like doing a calculation on some asset, to, for instance, all these applications of housing things and other Oracle-related data. You can periodically use these to calculate the metrics and feed the system. Can also be used for house automation and things like that. So at this time, please execute this script that's going to call this smart device and tell to turn on the lights, turn off the lights. So all scheduled work that you might want to have, it can be used in decentralized fashion.
Super cool. Yeah, an interesting project as well. We have one project around competitive programming. I don't think the team is here either. If I'm wrong, please unmute yourselves again. Otherwise, Carlo, I think you can give a little bit of a background on this one as well.
Okay, so this is another project from Ethereum India. And in this case, what they're tackling is this competitive programming industry. So there are multiple platforms in which you can go and you can take on some programming challenges. They basically run a test suite to see if your program does what it should. And then they measure the time it takes for the test to be executed in order to rank who's the winner. And sometimes there are also issues about the transparency of this process. how this is computed. People don't really have a way to verify that their competitors were actually faster, they had a more efficient solution, things like this. So by bringing this to Cartesi, this transparency is guaranteed. Anyone can just reproduce other competitors' software, check by themselves that it actually performs better than their own. If your own software doesn't pass some test, it's something that you can check. You can make sure that it wasn't tampered with, that a test was added later on that's not in the initial conditions of the problem you're trying to solve. So it basically adds a great deal of transparency to this ongoing industry.
Yeah, super cool as well. I think this is one of the last projects. The Nucleus project is also too early for them. I believe they're in San Francisco. This was from East San Fran. And this was also the one I mentioned briefly, Maxime, about the risk scoring. Carlo, do you want to kind of go over this one as well?
Sure. So this project, as Max said, was performed in Ethereum San Francisco. So the idea is they were inspired by the Mango hack. In the Mango hack, what happened is that a collateralized token that was accepted had very bad liquidity and high volatility. So this guy, he just purchased a lot of the token, and it pumped the price. And when it pumped the price, he just asks to lend a lot of stablecoins. And he presented this pumped token as a collateral. Since this Mango protocol runs on chain and doesn't have a lot of processing power or capabilities to calculate what's going on with the asset, it just went into our Oracle to get the price feed, and it checked that the current price would cover the amount that was being requested and lended to the guy. But he landed like 50 million stable coins with a much lesser amount he invested. So if the protocol was actually to liquidate those assets, it wouldn't get back the money. It would get far less because that was a low quality asset. So inspired by this hack, what these guys did is they developed this application, this risk analysis engine, in which they constantly feed the assets they are monitoring, price feed, and also the volume. And with both the volume and the price, they use NumPy inside the Cartesi machine to calculate a lot of KPIs that will establish the liquidity of the asset and also its volatility. And with that, they calculate a maximum recommended amount that someone could use that asset as a collateral. So that if someone gets some asset and presents that asset as collateral, when you liquidate it, you can actually get your money and avoid this Mango hack situation. So, yeah, I think that's the overall of the project.
Very cool. Interesting project as well. I think it's time for some discussions, AMA. If you have some about any of these projects or beyond, if you'd like to talk about something, now is the time. Feel free to either ask in a chat or to unmute yourselves, and we can have a little discussion about some of these projects right now. Yeah. In the meantime, while you guys think about your questions, Shaheen, maybe you can talk a bit about the Ideathon that we've been running in a Discord.
Yeah, sure. Can you hear me?
Yeah.
Yes.
Yeah. So hello guys. It's nice to see again so many faces on Discord and hearing voices of each one of us. So yeah, in run up to ETH Denver, we are having this Innovateathon what is it? It's we have so many ideas on our sleeves, on our mind when we think about Cartesi. So this is a place where you write those ideas. And it's not just about writing and forgetting them. We are giving away, we'll pick a nice idea which gathers some engagement and some reactions. We'll pick away one winner. You could be our idea wizard for this quarter, and you'll have some special Cartesi swag with it. So if you guys want to check this out, we are having this on Ideathon channel. I'll just post it here. Yeah, this is the channel you can see in the chat. This is the channel you can visit. If you have any idea, any cool idea that you want to build on Cartesi, or you want others to build on Cartesi, this is the place for you. Just create a post and express yourself. That's it.
Yeah, I love it. Shaheen, already some awesome ideas shared there. Some big brain stuff. I love to see it. But okay, I'd love to open up the mic to anyone else who'd like to ask some questions or share some ideas. Please feel free to unmute yourselves, and you can dive deeper into some of these projects. Come on, some of you must have some questions. There was some a lot of different projects.
I'll start you off if you want. More of an open question to yourselves. What sort of applications are you looking for? Are you currently sponsoring? What is sort of leading on your platform, and what types of use cases have you got there?
I would say that right now, we've seen quite a lot of on-chain games. Those are like the most, let's say, ones being most active developed right now. But we're looking for anything. We're not really restricting it to on-chain games. Like this, it's just kind of what the community has been wanting to build, and maybe it's also a good fit with Cartesi. But it is a general purpose computation environment. So we're looking for any types of projects. We're also providing grants to any builder that wants to build something new that showcases Cartesi tech that might be useful to others. So really looking for any vertical, even the ones that we didn't discuss today. I would say like anything that isn't like saturated yet too much. Or at least, the types of projects that kind of fill gaps that we currently see in Web3 are the ones that are interesting as well to us. But yeah, Carlo, curious to hear your opinion, or Shaheen.
Yeah, just building up on what Max said. So games is always an area that has a lot of interest. Another area that we have a lot of interest is these data processing applications. So BIMAcoin was an example. They process a lot of data for insurance. We had also that machine learning from application from India as well that was for house pricing. We had another application that was really interesting that did the same but for decentralized dashboards. We have another one that's being developed that is used to evaluate the quality of waters from rivers, the consumption, and cross-reference the data that's being provided by entities that consume that water and what you actually measure on the river. So all these applications that do something similar to big data are also an interesting vertical. We have multiple IoT applications that sometimes they cross the same section as the previous vertical I just explained. A lot of applications that use machine learning, ranging from games to data processing to all this kind of stuff. Carbon credits as well is an area that we have a lot of projects that are experimenting, prototyping, or developing. And that's because that's a market that really has an issue with transparency. Currently, we have these centralized entities that just mint carbon credits, and you have to trust them. So bringing that on chain is always a good idea. You can always check that those minted carbon credits are actually worth and that they should be minted. And you can check the data. You can redo the processing of all the models that's generated those credits, and check for yourself that nothing is being tampered with. And yeah, so I think those are the industries that have most interest at the moment. But as Max said, we're a general computation layer, so if you have a cool idea that you want to discuss, we're always available, and we're always ready to discuss it with you and to check what's possible, help you design the architecture or anything that you might need.
Fantastic. Indeed. Maxime, does that kind of answer your question?
Yeah, it's really cool. Just another question then, unless someone else has one. What's on your roadmap? When are you doing mainnet? When are you sort of pushing out to more validators? What's your decentralization plan from now?
That's a good question.
So basically, at the moment we're in testnet, right? So we released testnet on DevCon, which is when you were a part of our hackathon in ETH Bogota. And what we're doing right now is based on the feedback on a lot of developers and also the community. We're changing a bit some interfaces, improving some features and the ergonomics of our solution. And we're also doing a lot of auditing. Once it's stable enough, then we'll reach mainnet. But once again, it's not a process to be rushed because security is a prime concern of us. So no dates yet.
Cool. That's all my questions.
Awesome. Thank you, Maxime. Carlo? Would anyone else want to?
Yeah, hi, Ritvik here again. I have a question. It's like basically for our application, we require a lot of data to be pulled in from the vehicle, let's say, from an IoT sensor. So how do we manage this large amounts of data in this decentralized workplace? And also a follow-up question to that, while we were working in our Cartesi thing, so we had to get the data using this notify function. So my question is, how do I get a stream of data out of the machine?
Okay, so those are very good questions. So the first one is, we all know that putting data on chain, even on cheaper blockchains, is still extremely expensive. So one thing you can do for your application, and it's a design that I'm free to discuss further with you and go through it and adapt it to your application, is that you can actually use Cartesi itself as let's say a second level optimistic rollup. What you do is you have an application level protocol in which on chain you go and you say, so I've calculated this value for this data set. And you reference the data set by putting the hash of the source for it. Let's say IPFS, for instance. And then everyone that's running your application will go to IPFS, will download the data, will validate that it has that result that you claimed. If you don't share the data, if you tamper with it, if you tamper with the result or anything like that, then you actually move that data on chain and you redo the calculation inside Cartesi. And since that claim was made on chain, once you do that, your Cartesi machine will redo the calculation and will check that the results match the ones that you have claimed before. If they don't, then you lose the dispute and you're lashed. If they do, then the other party that's challenge you is lashed. So that's just the way you do, because you have the guarantee of Cartesi to check that no one tampered with anyone, but you don't have the high cost of storing data on chain unless someone disagrees with what was claimed. That's a possible design to ease the costs and still keep the security. And about the string, output string, so there are a couple of ways to do that. And one of the ways is exporting a database or something like that, and then you can query it off chain without having to go through the Cartesi machine for each request. Another thing we're working on, yeah.
So we have to go off chain for no, you're working on, sorry, yeah, continue.
Yeah, because then you can query whatever you want as many times as you want without hitting the Cartesi machine, and you can just go for the Cartesi machine for updating this data on this external database, right? That's a way you could do it, and we can also discuss other ways later on if you want. But one of the things we're working on is actually scaling more the read-only data from Cartesi computations, making this external state easier. It's one of the work fronts we're currently handling.
Okay. Thanks.
Awesome. Anyone else want to ask a last question? Otherwise, we will close this call. If anyone else has a quick one. Yeah. So, final touch. I think some of you guys already saw this. It's Eduardo from the Cartesi team was actually able to run Doom on Cartesi in a Cartesi machine, which is quite cool. I'll let the video play quickly. Yeah. So will it run Doom? Yes, it will. But all right. And to close it off, we will have a showcase page very soon. More updates on that, where you can find information on some of these projects, on all these projects, including links to who built it, GitHubs, etc. So you can better repository of what has been built or what is being built, these proof of concepts, etc. This is quite useful as well if you're trying to develop something new. As a last point, we will have a technical workshop at the same time in 1 week. So exactly the same time as this session, but in 1 week's time. If you're joining, please click interested so we know you'll be attending. And that's it from our side. Again, thanks so much for all the speakers, for all the attendees. Really great to see all of you and hear from all of you. Let's keep the conversation going on the Discord. If you guys have any questions or thoughts. Yeah, it was great seeing everyone. Cheers, guys. Bye.
Bye, guys.
Thanks, everybody.